Good day, my name is Lawrence, and in this video I'm going to be taking you through my design. According to the World Health Organization, an estimate of 1.3 individuals annually die because of road traffic crashes. This is an unfortunate aspect that occurs in all corners of the world, which claims a lot of lives along the process. To try and eliminate or to minimize a fraction of this incident, I have decided to create an anti-collision system. An anti-collision system is a system which alerts or assists the drivers to avoid imminent collision. If somehow a driver fails to avoid a collision, this system will automatically stop the vehicle as it monitors the condition of If somehow the driver fails to avoid a collision, this system will automatically stop the vehicle as it monitors the condition of the vehicle continuously.
Ultrasonic sensor. An ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic waves. On my design, I've used an HC SR04 ultrasonic sensor. It comes with 4 pins: VCC, which is connected to 5V, GND, which is connected to ground, Trig and Echo, which are connected to the digital pins on the Arduino Uno. PIR sensor. Passive infrared sensors uses a pair of piezoelectric sensors to detect heat in the surrounding environment. On my design, I've used an HC SR501 sensor. It comes with 3 pins: VCC, which is connected to 5 volts, VIN, which is connected to the digital pins on the Arduino Uno, GND, which is connected to ground. Arduino Uno Rev 3. Arduino Uno is a microcontroller board based on the ATmega 328P. It has 14 digital input and output pins, 6 analog pins, a USB connector, a power jack, and an ICP header and a reset button. A relay. A relay is an electromagnetic device that uses an electric current to open or close the contactor of a switch. The single channel relay module is much more than just a plain relay. It comprises of components that make switching and connection easier and act as an indicator to show if the module is powered and if the relay is active or not. In this design, my relay will be controlling two 3 to 12 volt DC motors using a 4.5 volt external battery. The last major component that I used is an I2C LCD display. This LCD will display the results of my 2 sensors. On this slide, I have my block diagram. This block diagram represents the hardware of my project. As you can see, the PIR ultrasonic sensor and the 5 volt batteries are inputs. Then the LCD, the relay, the pin, the piezo buzzer, and the LEDs are all outputs. The flow diagram represents the software and the operation of my design. I'll start by initializing the liquid crystal I2C display. Initializing all components. My ultrasonic sensor will measure the distance of approaching objects. If the distance of an approaching object is less than or equals to 15 centimeters, the relay will be energized, turning off the motors. Green LED will be off, red LED will be on, the buzzer will be high, LCD in the first row will print the distance of an object. If the distance of an object is greater or greater than 15, green LED will be on, the motors will be high, LCD on the first row will print all clear. The PIR sensor will detect movement around an object. If movement is detected, the blue LED will be on, the LCD on the second row will print the movement detected. If there is no movement, the blue LED will be off, LCD on the second row will print no movement detected. This slide clearly shows my circuit diagram and my schematic diagram in detail. The trick pin and the echo pin of the ultrasonic sensor are connected to pin 4 and 3 on the Arduino Uno. The red LED is connected to pin 8 and the green LED is connected to pin 6. The blue LED is connected to pin 7. The buzzer is connected to pin 5. The motion sensor pin is connected to pin 2. The relay is connected to pin 9. And the external battery is connected to the common pin on the relay. My motors are connected to the normally open pin on the relay. Now I'm gonna be taking you through my demonstration.
Okay, this is the physical representation of my design. I'm gonna be using my cell phone to power up the system. As you can see now, the system is now on. My LCD on the first row will be printing the distance measured by the ultrasonic sensor. On the second row, I will be measuring movement which is detected by the PIR sensor. I've used a 4.5 external battery to power up my 2 motors. Now I'm going to create a scenario whereby an object is approaching my vehicle. Now my motor is powered up. As you can see, it's running. Then I'm going to be using my hand to demonstrate when an object is approaching the ultrasonic sensor. When the object is less than 30 centimeters, my motor will be on. The green LED will turn off, turning on the red LED. When the object is below 30, the motor will be on. The PIR sensor will detect movement, turning on the blue LED. Demonstrating the full operation of my motor. Demonstrating the full operation of my motor.